In this video, we're going to be looking at some interesting algebra question here, right? So they say we need to show that this guy here, let me just get my pen. We need to show that this guy, right, is going to be the same as 3 basically. So we must show that this, when we simplify it, is going to be equals to 3. Let us do that, ladies and gentlemen. So here I have 3 to the power x plus 1 minus 3 to the power x. Remember, I said this on our previous lessons on exponents. When you have a plus or a minus separating exponential terms, you know you have to factorize. Ne? It can either be a common factor, a trinomial, or difference of 2 squares or whatever. But you need to know that exponents can also be factorized. So once you have more than one term, just like in this case, this is the first term and that is the second term. So you have term 1 here on the numerator, and then this is the second term. Once you have more than one term on the numerator and the denominator, it doesn't matter where. Immediately you have more than one term, you have to factorize, right? So let's do that. So we're going to have 3x, and then I'm going to say dot 3, 1. I'm splitting this one. Then you have minus 3 to the power x. And then at the bottom, you're going to have 3 to the power x multiplied by 3 to the power negative 1. Is still equals to root here. Let's call this left-hand side, né? Because it's on the left, the 3 is on the right. Sharp. Then, ladies and gentlemen, you always take out this guy, né, as your common factor. Only this guy. The one with what? The one with a variable x. It's your common factor. Né? Sure. So we're going to do this. Where those guys were, you replace with 1. So here we're going to put 1, we're going to put 1, we're going to put 1. Né? Okay, this one at the bottom, not necessarily, because it's just one term there. So if it's one term, we cannot factorize one term, remember. You can only factorize if you have more than one term. So here I'm taking the 3 to the power x out. Remember I said where it was, you put 1. So there you have 1.3 to the power 1 minus, then you have 1. Wherever the 3 to the power x was, you put 1. At the bottom, because it's one term, we're just going to write it that way. And then you have this. Right. Now, you can see, ladies and gents, that this guy and that guy will cancel. But I don't like showing the canceling to make sure that my work is neat. Ne? So I'll just cancel them in my brain. But don't show the lines when you cancel, guys. Ne? It's easier for the marker. Or use a pencil then. Use a pencil. Because some of you, the way you cancel, yeah. So now we have what here? We're going to have, let's see. We're going to have 3 minus 1. So that it gives us 2. Right. Oh, ladies and gents, I forgot plus 3 then. Eh? So there's plus 3 here. Right. Sorry about that. So here we're going to have 2 over 3 minus 1 inside the square root. And then we have plus 3. All right. And then we can see that our LCD is this guy. Actually, let's not do LCD here. Let's do this. Here we're going to say, okay, this guy here can go up. So we're going to have 2 multiplied by 3 to the power positive 1. When it was the denominator, it was negative 1, the exponent. Now it becomes a positive 1, then plus 3. And then you have 6 plus 3, which is square root of 9, because 6 plus 3 is 9, which is 3, which is equals to right-hand side. Now we have shown that this guy, that guy, is equals to 3. All right? So in the next question, it's going to be easier now. Always when you see hence, you know that they mean use the question above. So because they're saying hence, I know that, okay, I'm going to use the question above. And let's say, ladies and gents, you were not able to solve this one. You don't skip this. You can still do this one, even if you were not able to do that. Ne? I'm giving you test advice here, examination technique. So let's say you couldn't do this. And then, but they say hence, it means you have to use the answer above, right? And there will always be something common between these questions. Always, the questions of hence, there's always something common. If you check here, this guy is exactly the same as that guy. But this guy we showed that is 3. So it means I can replace this guy here with 3. So for this one now I have 3 equals to 1 over 3 x minus 2. All right. And then we're going to have 3 equals to 3 to the power negative 1. Remember here it's 1. I'm taking it up now. It becomes negative 1. All right. And then here it's x minus 2. Now the basis can, actually let's do this first. It's 3 to the power 1 equals to 3. Let's multiply everything with negative 1 there. We get this, right? It's minus x plus 2. Then the basis can fall off now. So you have 1 equals to minus x plus 3 plus 2. Ladies and gentlemen, to show me that you got up to the end of this video, tell me the x value in the comment section. Thank you very much. Aluta continua. Tango.